Hello. This is the first part of two podcasts on fractals, philosophy, music, and morphic resonance. First, it is important to know how a fractal is constructed. The Mandelbrot set is the most famous fractal, named after its eponymous discoverer, Benoit Mandelbrot. It has a very simple formula, Z equals Z squared plus C, whereby the results of the first solution is fed back into the equation to produce the next solution, and so on. So it works on a feedback loop. The solutions, which are complex numbers, are plotted on a complex graph that is based on a mixture of real numbers on the x-axis and imaginary numbers on the y-axis. The basic imaginary number is the square root of -1. Its description as imaginary is misleading. It is simply a mathematical device for circumventing tedious trigonometry. A full explanation is given in the material to podcast 6, The Quantum Cat Meets a Quantum Computer. The Mandelbrot set is an infinite and repetitive set, but with parameters. The reiteration of the feedback loop produces solutions, but only those within set parameters are included in the set. Basically, solutions which tend towards infinity are excluded. For example, when C equals 1 is reiterated, it heads towards infinity. And when C equals -1, the solutions oscillate between -1 and 0. Broadly, solutions less than 2 are included, the remainder falling out with the set. Three characteristics of fractals are that 1, they are self-similar and therefore scalable. 2, they're both deterministic and unpredictable. And 3, they can incorporate mathematically the phenomena of resonance. This is reminiscent of the theory espoused by Leibniz of a world composed of an infinite set of composable essences. What he meant by composable is that they could form a coherent whole while including infinity. If you want to find out more on fractals, please see the website for the Fractal Institute. Another astonishing aspect of the Mandelbrot set is the resultant complexity from a simple equation and set of parameters. Here is what Roger Penrose said about its discovery. Quote, "Not even Benoit Mandelbrot himself, when he first caught sight of the incredible complications in the fine details of the set, had any real preconception of the set's extraordinary richness. The Mandelbrot set was certainly no invention of any human mind. The set is just objectively there in the mathematics itself. If it has meaning to assign an actual existence to the Mandelbrot set, then that existence is not within our minds, for no one can fully comprehend the set's endless variety and unlimited complication. Nor can its existence lie within the multitude of computer printouts that begin to capture some of its incredible sophistication and detail, for at best those printouts capture but a shadow of an approximation to the set itself. Yet it has a robustness that is beyond any doubt, for the same structure is revealed in all its perceivable details to greater and greater fineness the more closely it is examined, independently of the mathematician or computer that examines it. Its existence can only be within the Platonic world of mathematical forms." Close quote. That is from Roger Penrose's book, The Road to Reality. So, even in the Stone Age, the Mandelbrot set existed, just waiting to be brought into the light of consciousness. One has to wonder how many other such mathematical objects exist. The Mandelbrot set is clearly of a different order than Plato's perfect solids, but ties in with Plato's theory of knowledge, namely that knowledge is recollection of, in Greek, eidos, which I prefer to translate as essence rather than ideas or forms, as it makes it easier to follow the arguments of subsequent rationalist philosophers. If the Mandelbrot set exists in this Platonic realm, then it can be reasoned that infinitely more complex fractals exist, which exhibit similar but more complex properties, including self-similarity, bounded infinity, and progressing through feedback loops. In this way, increasingly complex structures emerge. Plato's mechanics of recollection involves a soul inhabiting an ideal world of unchanging essences prior to being placed in the world of contingencies. This is too mystical for me, and the more plausible explanation may be that as each of us emerges from a fractal universe, we each carry part of that with us in a grosser form. As each life progresses, it then feeds back into the whole in much the same way as the reiteration of the equation in the Mandelbrot set. No information is lost, and much of it will be repetitive, and the evolution of such a system would provide the coherence needed for the anthropic principle to take root. One of the fundamental properties noted above of a fractal is its scalability. From the extremely small to the extremely large, it exhibits the same properties. This is perhaps most obvious with geological and biological structures, but what about atoms and the cosmos? The book, The Nature of the Atom by J.E. Cal and others, propose a fractal model of the atom, which they name structured atom model. One of their most important findings was identifying, quote, the growth pattern of the nucleus adheres to when growing in size and number of nucleons. This pattern is fractal in nature and is made up of icosahedrons that are connected. The pattern shows a doubling of icosahedron structures on top of each new completed icosahedron. Close quote. Their theory has no need of quantum mechanics, and in rejecting this and the existence of the neutron, paves the way for a better understanding of the cohesion of physics, chemistry, and biology. In considering the nucleus to be comprised of protons and electrons, the theory also provides a more rational description of radioactive decay. Resonance can also be used to explain the photoelectric effect. It is the frequency of the light aimed at the atoms in the metal that resonate with the vibrating electrons which release light at the same frequency. There is no need to introduce artificial photons, even if it does make the maths easier. It could be thought of as similar to Newton's cradle, where releasing one ball bearing to hit the stationary balls resonates to propel the one ball at the end, etc. Given that most, if not all, biological phenomena is fractal in nature, why would the constituent atoms be any different? On the larger scale of the cosmos, of which we only experience a part, we see similar structures and patterns throughout. Poincaré realized that the gravitational interplay between three planets was incapable of solution because of the mix of stability and instability, but also thought the motion was intimately connected with resonance. Quote, resonance pervades the solar system. It happens when any two periods have a simple numerical ratio. The most fundamental period for an object in the solar system is its orbital period. For example, the Jovian satellite Io has an orbital period of 1.769 days, which is nearly half that of the satellite Europa, with a period of 3.551 days. They are said to be in a 2-to-1 orbit-orbit resonance, close quote. The quote is from an essay by Carol Murray entitled Is the Solar System Stable?, included in The New Scientist's Guide to Chaos, published in 1992. The second part of this podcast will cover analogies with telecommunication systems, holograms, music, and how they all support Rupert Sheldrake's hypothesis of morphic resonance. I hope you can join me then.